Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Before you check out the Walk the Line and Walk Some Slopes videos demonstrating how to get an understanding of a constant rate of change as a slope when you're walking on flat ground or even walking some slopes, some hills. So here we're going to take a look at some important words and concepts to help us take this math perspective while walking the line and walking some slopes. Grab a pencil and some paper or a whiteboard to take notes as you listen, and I hope you enjoy. First, I want to speak of elevation, and it's helpful to think about an elevator because I walked a hill, I walked some slopes, and I was tracking my elevation over time. So my vertical change in height over time. So you'll see that it takes me much longer to walk up the hill. It takes me about over a minute to walk up the hill because walking up the hill is a slower process. So it takes me about a minute and a half to walk up the hill, and then I stop to talk to the camera. So I have no vertical change in my height, and then it's a much shorter amount of time, about 30 seconds to walk down the hill. So elevation is the height above sea level. And so positive elevation is above sea level, negative elevation would be below sea level. Talking about sea level, I walked right by a pond, so I assumed that the pond was at sea level, although in theory, it could have been above or below, but for the sake of my video, I considered the pond level sea level, elevation 0. As I went up, it was positive. I never really dropped below sea level. Slope is when a linear relationship is graphed on the coordinate plane. The behavior of the line can be described with slope. So, in my demonstration of my elevation over time, there's a lot of ups and downs and wiggles, and I use an average rate of change here to analyze it, but to clear up slope a little bit, you can think about negative slopes as decreasing from left to right. They're going down. A slope of 0 is a flat horizontal line parallel or on top of the x-axis, and then increasing slopes are going up from left to right. We read math graphs from left to right just like you would read a book in English class. So you can actually determine slope by choosing 2 points on the line. First, finding the difference in the y values. So here, if I'm looking at the origin, the point 0, 0, and this point, which is 1 and 1/2, you will be able to see that the slope is m equals 1/2 because I'm taking the change in the y values. So y is changing by an increase in 1/2. And then I look at the x values. X is changing by an increase in 1. So it's the change in y values over the change in x values. So 1/2 divided by 1 is in fact 1/2. So you're finding the difference in the y values and putting them over the difference in the x values from 2 coordinate points on a line graphed on the coordinate plane. Like I said, an average rate of change is helpful when your lines are not perfectly linear. So have a data collection relating to variables. You know, like the variables that change as you're climbing stairs or walking down a hill. Stairs in your house have a constant rate of change, but stairs built into a hillside likely have changing rates of change. So in the case of nature, an average is helpful to look at the slope of the stairs or hillside. Find your average rate of change by calculating the slope of the line formed by a point at the top of a hill or stairs and the bottom of the hill or stairs. So here's my starting point and the top of this portion of the hill, or I can go from here to here, finding changes in the direction of the elevation to make a straight line to estimate the slope or the incline of that part of the hill or staircase. If you are not able to access a hiking trail or a hill or something, just look at a picture and imagine you're an ant crawling along the landscape of the picture. So here, if you look, the first part of my picture from left to right is the decrease in the tree line, and it's a negative slope. The y value is decreasing as x increases, and it has a constant rate of change because it's a straight line. We continue on the tree line, and you see that it's parallel to the sea level, or parallel to the horizon line, parallel to the x-axis. So this has a 0 slope. The y value stays constant. There's no change. And then, boom, the trees pick back up again, and my camera's flip-flopped. So the trees pick back up again, and you see that that would be a positive slope if we used an average rate of change that was linear, and the y value was increasing here as x increases at a constant rate of change. But sometimes a linear relationship is not the best. In this case, maybe that tree part of the image is best represented with something like a parabola or a semicircle. And, a parabola is a quadratic equation where the x variable has a power of 2 on top. So what do you think? Is a linear rate of change even the best model for this part of the picture? And this is what we're thinking about on a hillside. If we think of it linearly, we can get the average rate of change even if it's not going up at a straight angle. Then the final thing to consider, negative slope, 0 slope, positive slope, is to think about undefined slope. Undefined slope is when the y values are changing infinitely and the x value doesn't change at all. Talking more about those in kind of with imagery is, drastic slopes can be like a mountainside. So if you're increasing, okay, you're going up from left to right. If you're decreasing, you're going down from left to right. If you're thinking about a hill, it's more of a curve shape, but you can still get the average rate of change. And when you get to the top of that hill, it's like you're constant, you're 0. And then if you're jumping off a diving board and you're just doing a pencil jump off of a diving board or diving straight down, that would be an undefined rate of change or an undefined slope. So undefined slope can be thought of as the steepness of a geometric graph when the y value is increasing and decreasing infinitely and the x value never changed. So think about falling rocks or, jumping off of a diving board. 0 slope is thinking like standing on flat ground, or if you're thinking about elevation over time, 0 would be when you're not moving up and down at all. Over here I have a cool graph about the speed of my hike in the vertical direction. So here you see a bunch of piecewise lines that are just 0 slopes because it's saying from, for the first 12 seconds I was going 2 units per second. And so I stayed the same speed. My speed stayed the same. Here I was going faster, and then it must have gotten steeper because I dropped down to a slower speed. And then the steepness must have shallowed out, and you can see this on the graph. The steepness shallows out, and then I'm going faster because it's shallower, and I can go faster if it's a shallower incline, right? So if it's steeper, I'm going to go slower. Then if it's shallower, I'm going to go faster. So that's a graph of speed over time, and if you are graphing speed over time, the 0 slope isn't saying that you're standing still. The 0 slope is now saying that your speed is not changing. So if you're going 60 miles an hour on the highway on cruise control, your speed's not changing. In this instance, I want you to make sure you're thinking about what does the slope mean in terms of what the y-axis and the x-axis are describing to me. If the y-axis is distance and the slope is 0, that means you're standing still over time. If the y-axis is speed over time and it's 0, the slope is 0, it means your speed is not changing. If your distance is the y-axis, your distance isn't changing, your position isn't changing. If the velocity of your movement is the y-axis, that means the velocity of your movement isn't changing, but you are still moving because you have velocity. Okay, I hope that didn't confuse you. It's just really important to think about what is slope modeling, what are the quantities that it's modeling. Slope equaling 1 is a 45-degree angle to the x-axis, and it is increasing from left to right as y increases by 1, x increases by 1. Y increases by 1, x increases by 1. Y increases by 1, x increases by 1. Okay? If it's a shallower slope, if your slope is between 0 and 1, that means you're going to you would be moving faster if you were graphing speed, but in terms of just thinking about position, that means you're not getting, for the same distance in the x-axis, you're not getting a higher elevation, you're getting a shorter elevation, and the angle is smaller to the x-axis. Negative slope is when from left to right, your angle is decreasing. So you're going down a slide, down a ski hill, down a sledding hill, and I like this little image of a skier because he's going downhill. Okay, so your starting point is often related to the y-intercept. Which of these 4 graphs has a starting point of 0? Did you guess the second one? You're right. Which of these graphs has a positive starting point? Did you guess the first and the third? Then you're right. Which of these graphs does not have a starting point? Did you guess the last one? You're right. So a starting point is where a relationship intersects the y-axis, the y-intercept of the axis that represents the y values. These are the words you need to know to be able to walk the line and walk some slopes with a mathematical perspective and be able to collaborate with others. I encourage you to do this activity with someone else because we learn best when we have others to talk about it with. I thank you for tuning in. Thank you for returning to your math practice. Make it something you enjoy so it's something you come back to day after day and week after week. See you next time.